is called exponential function. It's called exponential function where x is any real number, and a is always positive, and a can be 1. A is called, A is the base. A is the base. All right, student, this is an exponential function. That's how it's written. A to the power x. X is any real. That's what he said to you. X is any real, meaning the domain of exponential functions is all real numbers. Now, A is the base. You see, the number that carries the x is called the base. All right. And they said to you, the base always has to be positive number, but it cannot be 1. So from 0 to 1, you have to skip 1. And from 1 to positive infinity, it can never be equal to 1. Now, the reason being, why A cannot be 1, because f of x equals 1 to the x. You know what happened? 1 to the x is always equal to 1. That is the reason. If x is going to be any real, so if you have a 1 to the power x, you're always going to get 1. And that's going to give you a constant function. It's going to give you a constant function. That's why the base can never be equal to 1. That's the reason. Right? Base cannot be 1 because of that. So therefore, the base always has to be positive, but it cannot be 1. Am I making myself clear? This is the definition of an exponential function. See that? And remember what he said. He said A must always be positive, but it cannot be 1. X is anything, it's any real number. So therefore, the domain is all real numbers. Am I making myself clear? Someone should answer me, yes or no. All right, very good. Don't forget the rules. A is always positive. It cannot be 1. And I give you the reason. All right, Alina? Make sure you record this thing for me, all right? You didn't answer me today. I cannot hear you. Probably her microphone is now on. All right. Alina, are you there? Okay. So this is the definition of exponential function. Now the question is, example, of exponential function. F of x could be equal to 2 to the x, as everybody sees it. All right? Here, 2 is the base. Follow? It could be g of x equal to 3 to the x. Yes, 3 is the base. Everyone can see that. Or it can also be, if you want it, h of x. It could be 10 to the x. Yes, you all know that is the base. All right, student? Okay, the base is 2. Here the base is 2. Here the base is 3. Here the base is 10. All right? They're all exponential functions. Very good. Now that you know the exponential function, we'll try to graph it. Remember, once you know how to graph an exponential functions, everything else that we know about the shifting, whatever it is, apply. So let's see now how we're going to graph an exponential functions. All right, students? Very good. Very good. So can I erase this thing here? All right? So you want to write down underneath of this graph of exponential function. You got that? Very good. So those are all exponential functions. But I'm going to give another function here. I'm going to say, for example, k to the x. And I'm going to say the negative 3 to the x. Is this an exponential function? Is this an exponential? Why you say no? Alexandra, can you hear me? Because a is negative. All right, that's what you said. All right. So if you are given such, it is an exponential function because it's written like this: minus 1 times 3 to the x. So that's still an exponential function. Anyway, when we get to is an exponential function, the base is 3. The base is still 3. It's been multiplied by a negative 1. So all you're going to see later, you're going to see that the g here and the h here are simple reflection of each other with respect to the x line. You're going to see that later. So please, when you see an exponential written like that, don't think it's not an exponential function because you see a negative. No, the negative is not part of it. That this is exactly that. So this is still an exponential function. It is an exponential function. Is an exponential function. It is an exponential function because that's what it's written. The base is still positive 3. It's not negative 3. But if you have something like this, e to the x, that's a minus 3 to the x, this is not an exponential function, Alexandra. Because then this is here is not going to be an exponential function at that point. All right? So now you see the parentheses play a huge role here. With the parentheses, now the base is a negative 3 at that point. So there's no such thing as an exponential function with a negative base. This won't be bad. It is not. It's not an exponential function. This is not an exponential function. Because look at the way the base is written. But this is an exponential function. Because it's a negative 1 times. This one here, the parenthesis saying the negative 3 cutting the x. You see the difference between them? Very important, students. This is an exponential function. But this is an exponential function. Okay? The base here is still 3. The base is not negative 3. Alexandra, you get that? Okay, good. Good. I cannot hear you guys today. I don't know what happened. I cannot hear you today. I don't know. Can somebody, can you put your mic on and talk to me for a minute? One of you?
Professor, I think no one's talking, but everyone can hear you.
Okay, I cannot hear anybody today. Okay.
Can you hear me?
Miss Boris, can you hear me? I'm counting on you, all right? Record this thing.
Professor?
She cannot write, and she cannot. Okay. Good. Anyway, I think she's doing a good job. All right, Yuki Sao, take good notes. All right? I might need that later. So let's move on then. Can I raise this thing here, please? Okay, good. So now let's graph it. Okay. The graph of exponential function. Okay. For example,